Hello dear students, I am Professor Shraddha Pirke from KK Wag Arts, Commerce Science and Computer Science College, Kakasaheb Nagar. Today I am going to teach a new topic, structure and unions in C. Let's start with the structure. What is a structure? Structure is a collection of related elements, possibly of different types, having a single name. Again, structures are commonly used to define records to be stored in a files. The elements of a structure can be of same or different types. However, all the elements in a structure should be logically related with each other. So the structure is commonly a collection of data elements which are maybe of same type or a different type, but they having a common name and which are used to store different records. Let's see the syntax and example of the structure. Here, the syntax of the structure is this way. We have to use a struct keyword to define a structure. Then the tag or the structure name and the field list or the structure elements or the members of a structure are defined in the curly brackets and finally the semicolon. Let's see the example. Let's consider we are defining the structure for student. So the syntax will be struct student and in a curly bracket character ID of size 10. It is an array of size 10. Then name, character name of size 26 and integer grade points. Grade points are in a integer and all these three elements are enclosed within curly brackets and finally the semicolon. So this is a structure for student. We are defining the structure for the student which contains three elements which are logically related with each other. These elements are related to the student and each having different data types, maybe a common same data type or a different data type. So this will store one record for one student. Now we will see how to declare a structure using typedef. As we have known that typedef is a keyword which is used to define user defined data types. So we can create a structures using typedef also. So typedef struct and the field list. And finally, if we have a typedef defined structure, then we have to mention the type which we have created, that is a user defined data type that we have created. We have to mention this in the end. Let's consider the example, same example which we have defined earlier, the student. Typedef struct and character ID of size 10, character name of size 26 and integer grade points. And the student, this is a type that we have defined right now using typedef. Earlier syntax has the student right here. We have written the student right here. But in a typedef, when we are using a typedef, we have to define that new type at the end of the structure. Okay. Now we will see how to declare structure and its example. So let's see, we have seen two different structures or two different methods to define a structure or to declare a structure. So how we can create its members or how we can create the variables of a structure. Let's consider a student structure, struct student, and these three are its members and semicolon. And this is a global type declaration. We have to declare this as a globally and we are creating a local variables of this student structure, struct student and a student. This is a local declaration or local variable for this student structure. In same way, if we are defining the structure using type def, then we have to define a global type declaration as a type def struct and the structure, and finally the type that we have created, the student. And the local declaration requires only the type name and the variable. Just the way we create a new variable, in same way we have to create this local variable using this structure name and a student. So this is the difference between two methods of the structure declaration. Now let's see how to initialize a structure. To initialize a structure, let's consider the structure integer x, integer y, and float t, and character u. These four members are of different types and having a name sample. So if we have to initialize these variables, then there are two different ways. Consider sample, suppose sample 1, and the values are 2, 5, 3.2 and a. 2 is value of x, 5 is value of y, 3.2 is a value of t, and a is a value of u. And if we have not defined the values for any member, then that will be initialized with the its default values, like 0.0 for the t, as it is a float value, and u is a character value, so it will be filled by the null value /0. So if we are assigning only two values, then that will be assigned to first two members, that is x and y. Now let's see how to access the structure elements. We have seen how to declare the variables of a structure and how to initialize the variables of a structure. Now we have to see how to access the structure members. Let's consider one example like struct card. Card is a structure which has two different members, face and the suit. So there are two methods to access the structure members. First one is using the dot operator. So dot operator is used with the structure variables like card and my card. My card is a variable for the card. So if we have to access the members of a my card, that is a face or a suit, then that will be accessed using dot variables like my card dot suit, my card dot face, in this. And the second method is arrow operator. Arrow operator is used with the pointers to the structure variables. So this is a pointer that we have created for our card structure, and it has a value my card, address of my card. The pointer variables are the variables that access or that contains the address of another variable. So my card is the our variable, and we are assigning the address of this my card to this pointer variable. And if we have to access these members from the my card, then we can create this pointer, and using array operator we can access the members of this my card. How? The my card pointer and arrow operator and the suit, or my card pointer, arrow and the face, in this way. So the my card pointer, arrow operator and suit is equivalent to the pointer, to the my card pointer dot suit. It is indirection operator. This is an indirection operator, and using this indirection operator with the dot operator, we can access the members of this pointer variable. Now let's see how to define a structure within a structure, that is a nested structures. The structure written inside another structure is known as a nesting of two structures. The nested structures are allowed in our C program. So we can write one structure inside the other structure as a member of that another structure. Let's see how. If we are defining one structure known as a date, and date contains date, month and year. Three are the integer elements, and this is a date structure. And again we are defining one new structure known as a employee structure. Employee structure contains the information of the employee, just like character ename of size 20, integer ssn. Ssn is the number for the employee. Then float salary and struct date, that is DOJ. So in here, in structure employee, we are defining the variable of this structure date as its member. So this is known as a nested structure or a structure within a structure. So how we can access the nested elements? As we have seen, we have created one structure called as a date and another structure is a employee. So if we have to access the date objects, the objects or the elements of the date from the employee class, then how employee structure, then how we can access? Structure members are accessed using dot operator. Date structure is nested within a employee structure. So the members of the date can be accessible or accessed using employee. So EMP1 and DOJ are two structure names, that is variables. So if you have to access these elements, let's say accessing the month field in employee, then we can access it by using dot operator, just like emp1 dot doj dot month. So as a month is a member of doj and doj is a member of emp1. So in this way, using the dot operator, we can access the month field. In same way, we can access a day and the year field. Now, until we have seen these structures and how to define a structure, now we will see what is a union. Unions are same like a structure, but the memory that contains a variety of objects over the time. Then in union only contains one data member at the time. That is, only one member of a union is active at a time. The members of union shares a common space in a memory. Then it conserves the storage. As its members share the space, so it conserves the storage. Only the last data member that is defined can be accessed. That is, only one member is active at a time. How we can declare a union? The syntax is same as that of struct. Just like structures are defined, in same way the unions are declared or defined. Consider union number. As we have seen that we are creating the structure using struct keyword, so we are declaring the union using union as a keyword. So union number integer x and float y. Union number value. Okay, number is the union name and value is its local variable. Let's see some example how the unions are accessible or how the union members are accessed and how the behavior of the union variables. Let's consider one example. We have defined a union data, integer I, float f and character string of size 20, and this is a global declaration of the union. And in main function, we have created one variable of this data as a data. So in printf, we have mentioned the memory size occupied by the data, that is a union variable, is equal to %d and size of data, return 0. So when this code will be compiled and executed, it will produce the result like memory size occupied by the data is 20. How it is 20? Let's see. In union, there are three different members. So integer integer requires 2 bytes of the memory, float requires 4 bytes of the memory, and character requires 1 bit. So 20 substructure is of size 20, so it will be occupying 20 bytes of data. So in total, the member which have the greatest amount of memory size, that is only accessed by the union variables. So the common storage is used by this union variable is this 20 bytes only. It will be shared between these three variables. So therefore the memory size occupied by the data is a 20. Let's see what is the differences between structure and union. So first difference is in its keyword. The keyword struct is used to define a structure, whereas in unions, the union keyword is used to define union. In size, when the variables are accessed with a structure, the compiler will allocate the memory for each member, and the size of the structure will be greater or equal to the sum of sizes of its all members. And whereas in a union, when a variable is accessed with a union, the compiler will allocate the memory by considering the size of the largest memory. So the size of a union is equal to the size of the largest memory. Each member within a structure is assigned a unique storage area of a location. So each and every element will be stored at different locations, whereas in union, the memory allocated is shared by the individual members of the union. Value altering. The altering of the value of the members of will not affect the other members of the structure. Whereas in union, the altering the value of any member will alter the other member values. Accessing the members, the individual member can be accessed at a time in structure, but in union, only one member can be accessed at the time. Initializing of a members, the several members of a structure can be initialized at once, but in case of union, only the first member of the union can be initialized, as only one member is active at a time. So this is the difference between structure and union. So thank you, dear student. I hope you have understood the structures and unions.